just a little bit about myself. Like many of you, I've been in institutional research for a number of years, but most of the years has been spent in the U.S., Kennedy University in San Francisco, then Bastyr University in Seattle. And I've also served on accreditation teams with WASC. I'm an economist by training, so I grew up in Canada, in BC actually, so I went to UBC for my undergrad, and then I went to the University of Guelph for my master's in agricultural economy. My company is turning 3 years in August, and this year I've made it to round 2 in the New Ventures BC competition for some of the innovative kind of approaches to text analysis we're working on. And last year I was able to represent Canada on the G20 Youth Entrepreneur Forum in Japan. Currently there's 4 of us on the team. There's another developer as well who helps me, and a graphic designer and a marketing assistant. So just briefly about what text analysis is, just briefly, because I'm assuming everyone's in the right workshop. So natural language processing is a popular and rapidly growing field of statistical programming. It's actually also known as computational linguistics. It's an umbrella term for text analysis, and it describes the process of breaking down human thoughts into a format that the computer can understand. There are definitely many challenges and pitfalls, but they're really cool and exciting challenges to tackle, and hopefully we'll cover a couple of them today. So some of the most obvious ones are probably when you're dealing with surveys, unreliable grammar and spelling. But those are actually quite easy to address now. What's more challenging, I find, is working with institutional specific terminologies like acronyms. Those can be kind of problematic. But this is why I really enjoy NLP. I think in the age of these big words like AI and big data or machine learning, there's something kind of intrinsically still very human about natural language processing. So if you're overseeing surveys and responsible for analyzing them, many of you might be like me, wondering, what does 4.7 out of 5 mean? It's great to have benchmarks for your institution, but unfortunately, I hate to admit it, but it's the comments, the tedious and the daunting task of reviewing all that. That's where I think the actionable insights are. And on the right, you can see on the right here, this is an early kind of analysis we did 2 years ago now. This is when we looked at student loan complaints, student loan debt, and what we did was, I think the last time I checked, there's 57,000 comments, and that's just at a certain point, it just becomes really difficult to read it all by yourself unless you have like a big team. And so when we kind of identify the themes and mapped it against a graph, we could see that in 2018 there was 2 big issues that came out far beyond everything else, and that was students were receiving bad information about their loan and trouble with how their loan payments were being handled. So next, I'll share with you some case studies to show you the benefits of NLP in higher education. And so for the past 2-3 years, I've been really fortunate to partner with various campuses to deliver customized NLP solutions that saves time and produce actionable insights and ultimately foster a culture of continuous improvement. And this is for institutions both large and small. So I'll show you the first one. This is the first one. And this one, I just used a simple dendrogram or a hierarchy of words here to see the relationship. And the benefit of doing that is, we're able to find that this is for a student satisfaction survey, that, there is an issue with lab printers, and there's slow access, and there's, issues on campus. And with that information, we're able to, inform the president. And when he heard that, he said, that's it. We just need to replace 5 printers or 5 or 6 printers. So he approved it, got new printers for the lab, and then we were able to, write it in a response to the student. What that did for us was, I think it improved our response rates the following year, and it also improved our satisfaction rates. Because the students spend, quite a bit of time writing their responses, and to be able to, see that their voices have been heard is really helpful. And more recently, we've been working with climate surveys. Now, these tend to be a little bit more sensitive on campus, so I think the benefit of natural language processing here is that we're able to be less biased and more objective in our analysis. So similarly, we categorize the themes from everyone's comments. We categorize all the themes from everyone's comments. And then we can also find the associations between each themes and create different types of clusters. This one's closer to home. And so this is something I helped Thompson Rivers University with. We analyzed over 33,000 open-ended responses from their online course evaluation. And so we were able to find areas to help them inform their next survey build. And it's really important to stay objective, especially when it comes to strategic planning, when there's different departments kind of all being stakeholders on how which direction the school is going to go, which areas they should focus on, and how to kind of come together to form addressable goals in the future. And in this case, Bastyr University was going through a restructuring. So there's, tensions were quite high. And so, being able to come in, being objective again, and be able to identify certain themes really helps foster transparency and builds trust and buy-in. In this case, with their clinical restructuring, the biggest issue here was, exploring telemedicine. And lastly, we've also started doing interviews, live interviews, and within transcriptions, we can also analyze it for themes. What happened here was the school wanted to better understand their incoming students, where they're coming from, what challenges they have with transferring, and what the students felt are measures of success for them. So we interviewed about 25 students and generated about 180 themes. And each of these students had different personality traits. So it was just a kind of a basket analysis to identify the 4 common clusters. And these are kind of a little cute visual representations of the different types of incoming students the institution is receiving. Now I noticed there is a word cloud here. And it's very common, word cloud is usually the first type of analysis, and we'll see that in a little bit. But I think it's really important to, if you're going to make word clouds, is to make word clouds with at least 2 or 3 words, because it just gives better context. So at this stage, I'm going to share with everyone about 4 or 5 steps in the natural language processing pipeline. This is very common for any type of text-related analysis. So we'll take a look. Like any other kind of data analysis work, you'll quickly realize, natural language processing or text analysis is not very different in that, the pre-processing step takes a big chunk of your time. And it's really important to build this solid foundation because it'll make all your analysis much easier and create better insight. So this is actually from the data set we'll be looking at later. This is just one comment from a student who gave a review on Coursera. Writing a research paper is one of the most useful courses of all professionals, for all professionals. So the first step here is tokenization. What tokenization does is kind of breaking down your document or your sentence to each individual word. So as you can see on the right, we take the sentence, we clean it up, and then we break it down into each individual word. One concept that goes along with tokenization is a bag of words, which is literally like a bag of words. But it's actually kind of the core driving factor in a lot of search indexes. And then stop words. So there are a lot of words in our sentence that we use that when we want to analyze, it doesn't really add new information. So they're kind of redundant. And so we're using a package later, and this is what comes out of the box. This is all the stop words that you could safely, for the most part, remove and still keep the semantic of the original sentence. So you can see words like I, me, my, myself. Sometimes, though, you do want to keep the word not because it would change the semantic meaning depending on what you're trying to go after. If you're going to go after some kind of sentiment analysis, then words like not or negations become more important. They become less important if you're just looking for themes. And so this is what stop word will look like. If we take the sentence on the left and apply stop words, we'll remove it down, we'll cut it down, but we'll still be able to keep its semantic. Writing, research paper, useful, courses, professionals. Lemmatization is another very common step, and it's not removing lemons from your desk. It's actually getting to the dictionary word of your sentence, so that getting to the dictionary form of your word, so that you can analyze it as a single item. This step is really about reduction, because in text analysis, there's just so many ways to say the same thing. To have a way to distill it down to the same word will make it a lot easier. So in terms of lemmatization, for example, studies become the stem is study and the lemma is study. Studying, study, study. So with that, our sentence will look like write, research paper, useful, course, professional. Parts of speech. Parts of speech, this is what, how we identify what words mean in a sentence and what they represent. So for example, the smart student easily passed the hard exam. You can see this is a determiner, adjective, JJ, adjective, nouns, adverb, verb in the past tense, adjective, and noun. Before kind of getting into NLP, I only really knew 4 or 5. I knew adjectives, nouns, verbs, adverbs, prepositions maybe, but there's actually, if you can see from the table here, there's about 36 that have been kind of categorized in linguistics. And then now higher up in the analysis pipeline, we get into Engrams. Now Engrams is just breaking apart words and then finding how they're associated with other words around them, near or around them. So a unigram is just a regular tokenized sentence. You're just looking at one word at a time. And that's how word clouds are usually generated. They just take every single word and then you count it up. When you want to get more context, you start doing, bigrams where you're looking at pairwise words, or trigrams where you're looking at words in three sets. And with bigrams and trigrams and anyways, engrams, it's not uncommon to look at it forward-wise and backwards. And in some cases, you'd also want to skip every other word. And we'll look at an example later. Then now, a common visualization I enjoy making is building network graphs. And when I say graphs here, I don't mean pie charts and bar graphs. So graphs is a mathematical kind of theory used to study pairwise relationship between objects and entity. It's actually more common in the field of logistics and transportation to kind of see how long or what's the shortest route to get from A to B based on all the different transfer points. So airlines use it a lot as well to determine the optimal kind of number of transfers to make people suffer on economy flights. But in our case, it's actually very ideal for visualizing bigrams. So in the next section, I'm going to pivot a little bit and then we'll go into some code. So today we'll be using Colabs. Hopefully everyone had a bit of a chance to look at the link I sent out earlier. To get a little bit familiar, but if not, it's okay too, because I'll walk everyone through it. And this is kind of a relatively new platform. The notebook itself has been around for a while, but it's a great learning a tool because you can easily share the link and people can run the code without installing anything on their computer. And not to be confused with Team Coco. So this is Jupyter Notebook, everyone. When you log into this later, there's a table of content on the left that will go through each of the sections. And then you can see how much RAM Google gives you for free. You actually have 12 gigabytes of RAM and 100 gigabytes of space. So you can actually do some pretty decent data analysis on this platform. And if you want to, you can also include a GPU, which will give this notebook and give it some steroids. But everything we do today will be pretty quick, and hopefully that's one of the main takeaways of NLP you'll get from this session. So in a notebook, there's actually 2 types of cells. There's the text cell, which you can see here under Getting Started. And then here is the code cell. This is what we can run together and take a look. So what you can do is either just mouse over until you see the play button to run it, or you can always just press Shift-Enter. So, for example, if we want to print the statement, hello, everyone, we just press this, and there we go, hello, everyone. Yay, we did our run. We ran our first code together. So next step, let's load our data set. Today we're going to use Coursera course feedback that's available on Kaggle. Kaggle is one of the kind of main websites for data, people in the data science community or statistical programming community to get together and solve big projects together. The data set is actually 100,000. It's over 100,000 rows of data of comments, but we're only going to look at about 1,200 comments today. And what I did was I subsetted all the courses that involve academic writing, English writing, and just writing courses. I figured if you're taking English courses or writing courses, your responses should be, hopefully pretty free of grammatic and spelling errors. So I thought that would be the cleanest data set to work with. So to begin, we're going to first load our very first library, which is Pandas, and it's called Python Data Analysis Library. This is one of the most popular packages in Python, and it really helps with manipulating and your data sets and changing it in data frames and whatnot. So here we're going to import it. We're going to load data that I've hosted on GitHub, and then we'll display it. So let's take a look. So this is what the data set looks like. This is just 10 out of 1,200 something. So on the left, you can see these are the course names. In the middle is the comments. I like all these courses, and I score 5. Label is just the score. We're not going to really use the scores today, but it is helpful if you're going to go into sentiment analysis. It would help with your refining your models. Excellent. I would love to thank you for your hard work in something. Now we can quickly kind of look at how many rows there are with a count command. So yes, there's 1,297. So next, let's just build our first word cloud, because that seems to be the first thing most people do. And so I don't think you really have to worry about some of the complexity within this cell. I do some cleaning, like making all the strings lower, replacing non-alphanumeric characters. So let's just take a look. And so yeah, it just quickly processed 1,200 comments, and what we get is professors often excited, Amar, course apostrophe, courses apostrophe, course, and so it doesn't give you a lot of context. I think they're talking about professors, and some maybe successfully completed a course. So like in the next couple of steps, I hope we can get a lot better insight than the simple word cloud. So to begin, we're going to be using the natural language toolkit. Today, this is one of the the most established package for learning and training in natural language processing. I think it'll be great for covering the key concepts today. So in this next cell, we're going to first install it and then import it to kind of load it. And this might take a second. And let's see. Yeah, and it's done. You can tell if your code is done when the place sign is full or the number in the brackets are full. So the 4 steps, as I mentioned in our presentation, is tokenization, removing stop words, lemmatization, and parts of speech tagging. So we'll tokenize the comments now. So we'll import the tokenized module, and then we'll download the punctuation model. This is a pre-trained model that can kind of detect where to naturally break sentences and words. And then we'll clean it up a little bit, and then we'll take a look. So we're going to tokenize over 1,297 comments right now.
Recording is on.
So here's a preview of the first 5. Okay. And so we're importing a word tokenization tool. We're gonna make everything lowercase, remove non-alphanumeric characters, and so we applied all that. And so it just went through over 1,200 comments in mere seconds. So you can see the sentences are now separated by commas. I, comma, am, comma, very, comma, excited. and so forth. And so the next step, we'll tidy it up even more by removing the stop words. So it's just a matter of using the right library package and then downloading all the stop words for English. You can, if you're going to do other languages, I think it supports Spanish and German. A lot of the Roman and Latin-based languages are all there. So in this case, we're going to use the English stop words, and we can just take a look at what those words look like. So there it is. I, me, myself, we are. Now it's important. I don't show it here, but it's important. You can add and remove your own stop words too. So the reason you want to do that is, for example, as I mentioned, you might want to keep the word not if you're going to do some sentiment analysis. But more often, if you say, like, I went to UBC, if I'm going to do UBC related, text analysis, I really don't need the word UBC in there again. It's just kind of redundant because I know everything's going to be about UBC. So those are kind of the things. Like in the past, if I did a section on student satisfaction surveys on the cafeteria dining, then I really don't need the word cafeteria in there anymore. So with that, we can remove all the stop words with this function here, and we'll take a look at what that looks like. So I'm using our example sentence. It's actually in row 6 right here. So in our example sentence, writing research paper is one of the most useful courses for professionals. So after we tokenized it, we see it here, and then removing stop words, we have writing research paper 1 useful course. Next, we can do lemmatization. Again, so same process, we import the lemmatization module, and this time we download a pre-trained WordNet model, and then we can lemmatize it. So we initiate the function, the lemmatize function in the word lematizer to just make it easier and cleaner. And then we can test it on some English words, like dogs, kittens, students. So as you can see, dogs become dog, kittens and becomes kitten, student, student. So it's able to parse those pretty well. But when it came to teaching, it kept it as teaching. So when WordNet is a model of all these words that they've analyzed and put together for a model. If they don't recognize it, then they'll keep it as itself. And really the reason why it didn't recognize teaching as maybe teach is because by default it treats all words as nouns. And so this is where parts of speech becomes really important, because the tag you give the word is really helpful for the machine to recognize how it should, in a sense, conjugate the word into its dictionary form. So we'll add the verb tag in with the function. So V is for verb. And so if we look at teaching, teaches, and taught, and now knows, oh, that's teach, teach, and teach. So we'll take it now that we realize why part of speech tagging is important. We'll take a step back and re-lemmatize with all the parts of speech tagged. Now, so this is where another reason why NLP becomes really powerful, because we can, you'll see in a sec, we'll quickly be able to tag every single word in over 1,200 comments very, very quickly. So we will, import the tagging model. This is the average Percepton tagger, and then we'll apply it to all the words. And this is an example of just one of them. So you can see writing has now been associated with a verb, research, noun, paper, noun, research paper. So there is a challenge though, because if you're using packages that have been developed by others, you have to make your data conform to the type of input they're looking for. As I mentioned, there's about 35 different types of parts of speech tags. But in terms of the lemmatization model, they're only interested in 3. They're interested in nouns, verbs, and adjectives. But if you actually think about it, other types of parts of speech like prepositions don't really have much left in them to truncate. And so anyways, the next step, we're going to create a lemmatization function that will help us replace nouns with the N, verbs with a V, and adjectives with an A. So this is just initializing the function. And it's done. And then, so this might take a second or two, but we're going to lemmatize and tag them, and then lemmatize everything. 1, 2, 3. So that took about 6 seconds. So let's take a look at row number 6 again, every step of the way. It's funny, this one shouldn't take that long. Yep, so this is kind of the pipeline we've developed. The original text, writing research paper, writing research paper, and then writing research paper 1 useful, and then now with it lemmatized, write research paper 1 useful course. So I hope you noticed how we were able to simplify our sentences, and yet retain much of its original semantic. And the script only, it only took it a couple of seconds to run. So if you're dealing with, 30,000 student comments, it's going to just take you no more than a couple minutes. And so those are kind of the 2 points to reflect on. So one of the tagging model I mentioned earlier uses a greedy average method. I think it's important to note that the greedy algorithm is just one approach to solving optimization problems. In the case of this tagger, it picks the most obvious kind of parts of speech representation of a word based on a pre-trained model from Penn State. There's many benefits to this approach, but it can have trouble correctly identifying words that have multiple kind of parts of speech representations. It's also known as synonyms. So this is a comic from my favorite newspaper artist. It's very timely. It just came out this week. So it says, the plumber is telling the client, oh, the drain's clear now. It was just an ordinary homonym. So instead of a clogged toilet, he's holding a clogged shoe. So that's a challenge in natural language processing. Homonyms and synonyms, those are all challenges. So, and the word average means that the model was trained on multiple iterations, and then they took an average weight of each of the part of speech representation. So to say plainly, it's a fast model, but it's not perfect, especially when you're dealing with English words that might have more rare parts of speech representations. So you really have to use it with caution. And then when you guys try this at home or in your office, if you want to export the results, you could do that as well. So it's right here, I think. So just export to CSV file. Let me open it up. So I prepared this format for everyone. So you have your original comments, your tokenized comments, your removed stop word, your tagging, and then the final lemmatized and tagged. So there's all that. So it took seconds. And now we can get into text analysis. So we'll do some Engram analysis here. So as I mentioned, it's just Engrams are just kind of a sequence of items from a given sample of text or speech. And you don't have to break it down by words. You can break it down by syllables, letters, or you can break it down. You can break down a paragraph by sentence. So those are all grams. It just depends on the scope. So why you might want to do it by letter is if you're dealing with medical data like DNA blocks. And then you also can do it forward or reverse. And why that's important, especially when it comes into search. So Google always wants to make sure it delivers what you're trying to search for. So maybe you type in blue sky, but you're, because you're maybe interested in the weather, but you were actually interested in the color sky blue. And so that's where direction becomes quite important. And sometimes you want to skip every other word or every 2 word. And this is actually really helpful in building autofill or auto-completion. And so most of us on our smartphone now, when you're typing a response, it can suggest the next word for you, and that's because, it's built on this kind of theory. So, you would purposely remove a word and like the cat something on the mat. And so you could train it over a lot of different iterations and a lot of text. So, and then Google will find out, for example, that, sat is the most popular search right now. So let's, suggest sat, the cat sat on the mat. So, and here I'll show you how to do it here. So we're going to, again, import some helpful functions. And the reason we're importing these functions is like you don't really want to reinvent the wheel because it's already built for you, and so it's kind of like Lego. You just want to know and recognize the right pieces to use to build your next project. So we import a counting function and then a general Engrams function. So let's load that. And here we can specify, if we want bigrams, we'll do 2. If we want trigrams, we'll do 3. And then apply it to all the sentences, and then we'll count it, and then we'll create a data table based on Engrams on one column and count on the other. And then we'll just sort, and for the purpose of this workshop, we'll just keep the top 40. And then we'll output the results. So again, it was really quick. That was less than a second. I just showed a little bit of the top 5. So right now we'll suddenly, now we can see that, great course is one of the biggest topics, followed by peer review, writing skills, an excellent course, and learn a lot. So now we have a lot more context. So if we want to do it with 3 words, we could do it as well. We change that to 3. Now it's a little bit different. Now, when you're looking at 3 words, writing for young readers, perhaps, improve writing skill, course, learn a lot. It was a great course for possibly learning, and really enjoy the course. And you can keep going until you reach the limit of your sentence length. But we'll keep it at 2. And as I mentioned, we'll visualize it with a network graph. So to do that, we have to, again, conform our data set to the package that we'll be using. So this is just changing and manipulating your data set into a dictionary form. And a dictionary form is just a way of holding information where there's an index column followed by a value. We'll import some of our visualization tools like Matplotlib, NetworkX. And I'm importing Google Colab here because it'll help us export the results later. Just a little bit of a short run through here. We're going to initialize the canvas. Then we start creating all the connections between all the different pairwise words. We start plotting the network and giving it some color. They don't need this color, but okay. Giving it some color, and we're not going to label it because we're going to create an offset label so that things don't, clutter together. So we don't need this one. So yes, and here we're creating the label, and then here we'll show it. Oh, let me see. Run. So here, this is our network graph. So you can see the topics: peer review, much thank, so people giving gratitude, and a lot of positives about the course. They love the course, they enjoy the course, a nice course, wonderful course, amazing course, very positive. This is Coursera has a very good program. Helpful course. And the word help is associated with course, and also it was helpful because, they learned a lot. And what did they learn? They learned about business writing, they learned about academic writing, they learned about essay writing, and they learned about improving writing. And I guess there is a course about writing for young reader, and that's why that came up as well. Now, when you're running this on your computer, if you want to export the graph so you can put it in your report, just remove these hashtags, because that's how you comment out a code, and then run it again. And the file will be saved as network graph Coursera as a PNG. But you could, if you wanted to, like for more publication, you could change this to SVG as well. So let's do that. And you might get a pop-up here. Hey, will you allow? And go yes. And oops, it's showing up on my second monitor. I just have to drag it. Sorry. Here it is. Now you have your own graph you could put in your report. Now, depending on like the format, you might want to play with the size of the report and the dots per, or the DPI, to maybe something of a higher resolution. It depends. If you're going to be in a PowerPoint situation, you might want it to be at maybe 300. And last but not least, to complete the circle, we'll go back to our word cloud. But as I mentioned, word clouds are better with more than one word. So let's do that with. Right now we have it on 2 words. So now see, when you do a word cloud with more than one word, you get a lot better context. So now we know there's a lot of positives about the course, like great course, excellent course, thank you very much, good course, and some of the areas that people are studying, maybe business writing, writing skill, essay writing, like that. So that's the word cloud. Again, if you want to export it, just do it like this, and it'll come up. I won't do it again. Yeah, and you can also control the size here, width and height, and number of words you want it to show. I put in 500. So that's the code. So hopefully you guys will try it out later on your own time. If you have any issues, I'll provide my contact information. You can reach out, and I'm going to switch back to the slides. Give me a second. Okay, so some recommendations. I think it's really important to keep open-ended questions on your survey very succinct. I know it's really, people like to have a catch-all comment in the end of the survey, but more often than not, I find that to be more work in the end, because then you're getting student feedback or faculty feedback on any question throughout the whole survey, or maybe even something completely very different. You're still able to parse it. It's just extra work. I mean, so I actually prefer it when institutions break up their open-ended questions into each of the relevant sections to kind of keep people, encourage people to write to the question or the section on the survey they're in. And that way too, you can actually limit the characters. I actually recommend, keeping it short, less than 128 characters. Would be the ideal for the text analysis. So that's one recommendation. And then the other one is I didn't show it here, but I usually have a script that does spell checking right at the beginning of the pipeline, and that also improves the quality of your results drastically. Spell checkers now are able to quickly parse through all your sentences. They are able to catch slangs, abbreviations, and most typos. The way they work too is typically you specify kind of a confidence index, maybe 80%. If you feel like the word matches the intended word by 80%, then switch it. If it's below that, then ignore it. So those are how kind of spell checkers for text analysis work these days. And definitely, you should build custom dictionaries for your institutional lingo, acronyms, terminology, because the machine is great. They know words very well, but when it comes to acronyms and institutional lingo, there's no kind of training they'll have to know things that are unique for your institution. That's actually one area too that we kind of work with our institutions with. To kind of build that out. And what I noticed too in doing this for the past couple of years, is the biggest category and theme might not always be the most interesting. So in the case of course evaluations, the biggest theme sometimes can be 40 or 50% of responses. It would be students saying there's too much homework or too much reading for their class. So that might be the biggest topic, but it's not something you probably address for your institution. Whereas if you start drilling down a little bit further, you might identify things like broken links in the course, or some things that are more important, like students saying the learning outcomes they felt didn't match what they got out of the course. And you can probably remove adverbs as well, and that's where parts of speech tagging comes in. So adverbs I find don't really add value to the analysis. Very, or really. So that kind of those words. Future topics. It's not covered here, but sentiment analysis is another area. So things in NLP, this is just a kind of a general overview, but things can move, very quickly from relatively simple positive to negative scales for all your sentences to some of the things we're working on now, such as unsupervised sentence clustering. So this is actually a visualization of a project we're working on now where we're training the machine to differentiate thousands of comments and clustering sentences with similar semantic meaning together. So there's 16 colors here, and we're able to kind of sort it out into their own clusters. And then depending on the complexity, we can sort it in different ways, and that's what the visualization is telling us on the right. And so yeah, it's a very exciting field, and I'm very happy to be working in this space. Additional resources. So it's like a shameless promotion, shameless self-promotion. My friend and I do have a Python podcast called Python Out Loud. And this is a book we recommend for those of you interested in learning more about Python and wanting to catch up to speed relatively quickly. This is a free ebook. It's all free. Jake is a well-respected leader in the Python community. And it's designed for folks who might already have experience in other coding languages like SPSS, SAS, or R. And on the right, another free book. So the other great thing about the Python community is everyone's really, really generous. So this is another free ebook just on natural language processing for Python. Now it's a bit of a steep learning curve especially if you're just starting out with Python, but it's there as well. So these are the two resources. And so thank you, merci. Now the only note I want to just kind of put out there is that we're competing in a startup program to build an NLP platform for higher education. So right now we're actually seeking partners to help test and advance our models. So we're seeking partnerships in this space. If you have some untapped, open-ended surveys that you haven't really looked at in a while, we're happy to kind of analyze it for you, and in return, you'll help us improve our model as well. So if you go to kaianalytics.com/workshop, you can complete a form, and by doing so, you actually get the code and the presentation as well right away. But then we'll be able to follow up to see how we can help you with your open-ended data, and you can help us a little bit as well. So thank you very much.